and in this video, I'm going to be walking you through everything that you need to know to ace any front-end system design interview. The nice thing about this video is that it can be applied across any front-end system design interview, not just specific questions. This video essentially contains all the material you need to know to pass any front-end system design interview. There's obviously a lot of topics covered in this video. For instance, on my screen here, this is the rendering performance when we look into how we can improve rendering for a page. We can talk about topics such as tree shaking, error handling, time to interactive, virtualization, and so forth. But this is just one of many topics that we'll be covering in this video. We're going to be covering things such as discussing the pros and cons of various HTTP protocols like GraphQL, WebSockets, REST API, why one is better over the other. We're even going to be discussing the difference between HTTP 1, HTTP 2. Then we're going to be taking a look at the client-side model on how to actually create your data types on the client, your API design, and so forth. So obviously this is a lot to learn at once. This can come across pretty overwhelming, but I am actually going to discuss a framework called R.A.D.I.O that helps simplify this entire process so you know exactly what to focus on, how to start, how to structure your interview. So even though there's a lot of concepts here and I'm going to try my best in this video to explain all of them, there is so much to learn and it's hard to sort of digest all this material at once. That's why I essentially created a platform called FrontendLead.com where I have this entire course and curriculum for system design and as well as just general coding questions that are asked by top tech companies. And I've aggregated all these questions into one website called FrontendLead.com, which has a vast amount of questions with solutions. So right now we have over 100 questions with solutions, which include system design. Each question showcases the solution. A lot of questions have videos, and it has the solution here. And finally, it also has an article style format to explain how it's done. And there's a lot of questions here. So really, this is the only platform you need if you're preparing for front-end engineering interviews. Check out FrontendLead.com. Do want to mention we're offering a 10% off coupon. So if you use the code 10OFF, right here on the header it says it, you will get 10 off the annual plan. So check out FrontendLead.com. And with that, let's get started with the video. So R.A.D.I.O is nothing more than an acronym that stands for different steps that you can go through your system design interview. So let's look at each one here. So I'm going to zoom in here. So the first is requirements. And right now I'm just going to talk about this at a very high level, and then we're going to take a deeper dive into each individual bullet here. So first, requirements. Requirements are just asking functional and non-functional requirements. You're basically trying to understand what you need to build this platform, application, whatever you're asked to build, the core features there. And then you can discuss the non-functional requirements as well. I'll get into that in a second. The next is the high-level architecture. This is where you're essentially going to design the architecture, all the components and subcomponents that takes to build this feature that you're requested to ask. Now, you don't want to dive too deep into each individual component unless your interviewer asks you to do so, but you want to show just the overall high level of how things work. The next is the data flow model. You want to design exactly on the client how this data will look like, the store itself, so each individual data type. The fourth is the API model. You want to discuss what sort of HTTP protocol you're going to be utilizing to pull the data and why, the trade-offs between each one. And then once you decide on an API protocol, then you want to actually create the API layer. So you don't want to go into the back-end side of things, but you just at least want to discuss like authentication, the URLs for the APIs, what kind of API request will it be, and so forth. Last but not least, and this is where you're going to be spending the majority of your time in the interview, is optimizations and performance. So you're going to be talking about various optimization techniques from network performance to rendering performance. Then you can also go into security, you can go into accessibility and so forth. So this is where you want to spend the majority of your time. So now let's first look at requirements. By the way, I've already have these built up so that we don't spend any time writing this out in our video. And just to let you guys know, this took me quite a long time to build, and I really just built it for YouTube. So if you appreciate it, just take a second and just press that like button. It will help me a lot. And if you want to support the channel, again, check out FrontendLead.com. Cool. So first is functional. So we want to spend 10% of our time talking about functional and non-functional requirements. So let's use an example. Let's imagine we're asked to build a Facebook newsfeed, okay? Your interviewer tells you, hey, I want you to design Facebook. That's all you know. So it's your job to understand, okay, what are the core features that I actually need to design? Because Facebook is so vast, you don't want to focus on all the various features there. You just want to focus on some key features. And this is more of a collaborative approach that you want to work with the interviewer with. So in our case, let's focus on just 4. So we want to focus on a feed that displays a list of feed items. These feed items can include comments. We're only concerned about the user post type, because there could be various post types like sponsored posts, video posts, and so forth. So we just are really concerned about user like text and image posts maybe. It should support infinite scroll. So as you keep scrolling, we should load more content. So those are the basic functional requirements. The non-functional requirements, now these requirements are a bit more to discuss like who are your users actually? Like, are we only targeting mobile users? Are we targeting only web users? Are we targeting both? This will help you strategize how you're going to create your UI and your interface. Then you can ask, does it need to work offline? Do we need to like access this data beforehand somehow? So we need to persist this offline. In this case, it's a nice to have, but it doesn't need to have offline support. Then you can also talk about accessibility. Does it need to be accessibility friendly? Most applications should be accessibility friendly, but some, depending on your demographic, might need to be even more accessibility friendly than others. For instance, someone who has a hard time seeing different colors might need to consider having even higher contrast there. Then we can talk about supporting internationalization, which is essentially where your user is located. Is this just located in the US or is it located globally? So if it's located globally, we want to make sure the strings are translated as expected. Then we talk about performance too. Obviously, everything should always be performant, but some designs, some app requests need to be more performant than others depending on the feature request. So we'll try to have a good latency here. And then last but not least, it's a nice to have, but it's nice to have a napkin math idea of your expected volume. Now, this really just helps us with estimating for observability. And observability is essentially, okay, I released and built this feature. I want to understand what the volume is coming in so that I can track this and view it in real time, maybe using Datadog or another observability tool. And if we never estimated how much volume we're getting, we're sending a bunch of logs to Datadog, and we can overwhelm Datadog or this other observability platform, and it can cost us a lot of money. So it's good to just have a napkin math idea of what your expectations are. For instance, you can say that we have about like 50,000 users on a weekly basis, or a WoW is 50K users. And then you can multiply that by 4, and that's your monthly users. And then you can multiply that by 12, that's your annual users, and so forth. Then you can try to estimate if things will scale up and down, and so forth. So that's where your napkin math can come in handy. Now, let's get into the next part, which is high-level requirements. So I do have one created here for high-level requirement. When it comes to the high-level requirements, you want to spend about 10 to 15% of your time here. Start off with designing a simple UI of what your end product should look like. It doesn't have to be perfect, but just a simple UI design. It'll also help you understand your component design. In our case, if we're building a Facebook newsfeed, we'll have a header, then we'll have a post composer where you can create posts. Then you have a feed item. Actually, you can have multiple feed items, and then each feed item will have its set of content, like the person's avatar and their name and the post text. And I do forget to mention up here in the functional requirements that we want to support post composer. Let's for now just say it's a nice to have, but if we have time at the end, we can cover post composer too. The next is designing the component architecture. You actually want to go into and discuss the high level component architecture? And in our case, it could look something like this. So imagine we have our black box server up here. Might be hard to see. Let me zoom in. We have a black box server, which is essentially eventually going to communicate with our client. So we have a client here where we have index.js. That's our app entry file, essentially. Our index.js essentially is talking to the API, which is returning us JSON data, right? This index.js eventually sends data to our controller. Our controller is responsible for bringing in that data coming from the API, manipulating it, parsing it, so forth, so that we can actually store it into our data model store. This is like our high-level data model store. And then our data model store will essentially send that to our view application layer, which contains all of our view layers. So it contains our feed container, our post composer, our feed items, and so forth. Each view layer can have its child components and so forth. So that will handle the initial rendering. But then we also have to keep in mind that some of these subcomponents are interactive, right? So for instance, if you create a post composer, you create a post, it should communicate with our controller. And the controller, and actually this one should not be here. So our child components can communicate with our controllers. Our controllers are now communicating with our API. The API is now updating the data model. Then the API returns data back, speaks to our controller, stores in the data store, and then updates the client. Now there can be network updates to the client, or there can be client-side updates too. So either way, our design pattern here is MVC pattern. And that is something that you want to discuss. Discuss what design pattern you want to use and why you want to use it in the first place. So really, there's a lot of different design patterns. My go-to is MVC. It's mainly because MVC has the model view controller pattern. It's really easy to sort of organize your code. And each component has its own purpose. For instance, the controller is designed to handle all of the business logic, all of the interactive logic, all of the logical part of things. Your model is essentially where you're storing your data, and then your views are essentially where it's rendered. So it's a clear separation for each individual purpose. You also want to discuss how your data will flow. I kind of already walked us through that. And finally, explain exactly how your interactions will work too. So that is high-level architecture. So let's move on to the next one now. So next up, we have the data model, which will be covering about 15 to 20% of our interview. This one, in my opinion, is more straightforward if you have experience with it. However, it could be a bit challenging to others. But you essentially want to build the data types that will render your client. These are client-driven data model. So for instance, in our case, we'll have a main app, right? This is our main data model. This will contain all our high-level information we need to use our application. So we might have like a user type in there, which is just signifying ourself and our own maybe preferences and so forth. And then we have settings. Maybe settings could be part of users. But given that settings is basically for your logged in user, I decided to keep it separate. Then you have your feed. That's what we're really concerned about with this specific ask. Then the feed itself can have items, which is a list of feed item. And then it has a page and a size. Page and size represents paginating and how you can actually request and receive more content. Then we'll have feed item itself, which will have a type of feed item type. So this is representing the post type. Then we'll have creation date. We'll have the author itself of the post. We'll have the content of the post, which is a feed item type content. Then comments, which is a list of feed item comments. If I scroll here a little bit more to the right, this is what the user looks like. It'll contain user metadata. User settings will contain their preferences for themselves, like accessibility preferences, time zone, etc. The feed item content, which is essentially the content for every single post, will contain the post metadata like title, body, and media. And if you notice, I put style text here rather than using just regular strings because we want to essentially make our data server-driven UI, meaning that our title, our body can contain rich text. For instance, our body can contain app mentions, it can contain links, and so forth. So our clients should be smart enough to be able to parse that style text type and actually render all of the content that we need based off of the style text type, not just a regular static string. So that is a client data model in a nutshell. Now let's move on to the next type. So now we want to discuss the HTTP protocols and the API design. So the API design, first and foremost, you're going to be discussing what HTTP protocol to use and why. Before we dive into what API protocol you should use, like GraphQL, WebSockets, and so forth, let's first talk about HTTP1 and HTTP2. This is useful and important to also let your interviewer know that you understand the differences so that you can sort of discuss your choices later, like why you're choosing GraphQL or WebSockets or long polling and so forth. So what's the difference between HTTP1 and HTTP2? Well, HTTP1 had a limited number of connections that it can handle at once, meaning that because if you're opening a single TCP connection, and you're trying to request resources, there's a synchronous blocking queue, meaning imagine you have an index.html page, you're trying to load your main.css, then you're trying to load another script and so forth. Well, it's going to be synchronous because you're opening one connection at a time. So now you have to wait until your main.css is loaded, then your JavaScript is loaded and so forth. So it's quite slow. The other limitation with it is that it returns plain text, so it doesn't support rich media and rich data there. The other downside with it is that you explicitly need to close the connection when you're done with it. And yes, I already mentioned this before, but it's a single TCP connection that sends one data point at a time. So HTTP2 solved most of these issues. The first being is that it solved the limited number of connections issue by introducing multiplexing. Multiplexing essentially allows you to connect multiple connections rather than just connecting and handling one connection at a time. And the benefit of that is that it can take parallel requests. So you don't have to wait for one request to finish after another. You can handle multiple requests at once. One TCP sends multiple streams of data at once, not just one at a time. It also supports rich data, and it has better compression compared to the previous HTTP1 using the HPAC algorithm. So that is basically when you are requesting and receiving data, the data that you receive back is compressed better, which means that it's going to be a faster connection overall. So now let's look into each of the API design and talk about the trade-offs between them. So the first is polling. So polling / long polling / a regular HTTP request. So the pros of it is that it's simple. It's pretty industry standard to send an HTTP request. It's easy to load balance on the back end. It's HTTP2 compatible. But the cons there is that it has longer latency. You could time out connections. Cons first and foremost is that it has a longer latency. You are sending request headers. You're sending a request body, and then you're waiting for that. The backend has to parse that data, authenticate users, and then return it back to the client. And then it returns back the response. It could be various formats. So it does have slightly higher latency there, which can result in connection timeouts and traffic overheads. The next is GraphQL. The pros there is it's very modern. I'm pretty sure it came out within the past 10 years. It's easy to load balance because it follows the same HTTP2 protocols. The big benefit of GraphQL is that you pull the data you need. So for instance, if we have a Facebook feed that we're returning, right? In a RESTful endpoint, the backend would have to do all the calculations to request all the data we need to render our client. But imagine if we have a feature request where we need to have an additional button or something that needs to be rendered, then the backend has to completely build that and then return that to the client based off of the RESTful response. But with GraphQL, because in the backend you can create these different schemas, and each schema has its own responsibility. For instance, you'll have a user schema, you have a post schema, and so forth. You can essentially connect all these different schemas together on the client and on the backend and request what you need. So you pull the data that you need. It's a lot more performant because you're not pulling way more data than necessary. And it helps with latency too. And it's also type safe. You can generate a lot of the fragments on the client automatically with GraphQL, so you don't have to build those yourself. What are the cons? So the first is that you have the potential to having longer latency. If you end up on the client connecting all these different nodes together, because you don't have any limitation on the client, you can connect as many nodes as you want. In fact, you can, if your backend is configured in a way, you can literally pull the entire backend at once. So it does have longer latency in that regard, but obviously use it with the right approach and you shouldn't have issues. Could have connection timeouts due to the longer latency, and it also has the same issues as HTTP2, like traffic overhead. The next approach is WebSockets. What are the pros of using WebSockets? First and foremost, you have bi-directional communication. So you open up one single TCP connection to your server, and you can send information in, and you can receive information with the same connection in the same session, because you're having an open connection communication at the time. This enables you to have a lot more performance. You have a lot more speed because you're able to send and receive data based off of that one open connection. Cool. And the cons is that it can become harder to load balance because you don't have your regular HTTP protocol to follow. The backend has to worry about how it can load balance and scale things to be able to handle the traffic coming in from the client. Because every single connection that's open essentially takes up more memory on the backend, and also on the client too, but mainly on the backend, because imagine you have 100,000 connections happening in a second. Well, one backend server cannot handle that load, right? So you need to horizontally scale the backend so that you have multiple servers in the backend handling that load, and a load balancer. In fact, you might need to have multiple, like hundreds of load balancers to distribute the traffic evenly to the backend. And you can use some sort of like hashing strategy for that on the backend. You can use like consistent hashing so that things are distributed equally, and if like one server goes down, we're still able to direct the traffic to another server, and so forth. So you can use different strategies like that, but yes, it is harder to load balance, so you have to sort of build a lot of that yourself. I already kind of discussed resource intensive and firewall issues and proxy issues. Again, it's not an HTTP request, so yes, you do have to sort of consider and think about all these things and construct them yourself. Is server-side events. The next is server-side events. The pros of it is that it's efficient, it follows HTTP2 protocol, and it's easy to load balance. The cons, it's unidirectional, server to client communication only, meaning that you can send data from the server to the client. That's about it. It has limited data types. Basically, it mainly just returns plain text, and it can be hard to use. In your interview, it's good to sort of discuss at least 2 or 3 of these different API options, and then you would want to select one that you want to move forward with. In our case, I think using GraphQL seems like a good solution here. So next we want to discuss performance, and this is where you want to spend the majority of your interview time. There's various things to discuss in performance. You want to discuss optimizations, security, accessibility, observability, and tracking, and so forth. So let's start off with the first one, which is your network performance. So there's a lot you can do on the network layer. So first thing is you want to use an HTTP. You want to try to use an HTTP2 protocol if your design supports it. For instance, if you're using a chat application, or if you're building a chat application, maybe you might need to take a hybrid approach for where when you're sending and receiving messages, you might need to use WebSockets because it's real time. You want the data to be visible right away. But if you're building like Facebook, for instance, you might not need to see those feed items like instantly. You could wait maybe 100 milliseconds or 150 milliseconds or so forth. So with that, you can use an HTTP2 protocol, and it supports multiplexing. So that is your network option. Then you can think about different ways you can optimize your network performance. So first is compressing the headers using the header compression when you're requesting data from the server. There's a modern compression out there called R.A.D.I.O. This was created by Google. I think it's somewhere in 2010 or so. And that is just a slightly more optimal compression algorithm compared to gzip. It just helps deliver the data faster. You basically send these headers in each request that lets the server know what sort of compression algorithm is supported. That's basically compression headers in a nutshell. Then on the network layer, you want to think about various caching strategies. Now there could be several, but for the most part, your server should be caching some of the data itself to make things more performant. But on the client, you can also do level of caching. You can do Apollo caching, which is caching that is built into GraphQL, so that you can, if you're receiving the same requests, you don't have to necessarily worry about building that caching layer yourself. You can utilize Apollo caching and set some sort of expiry date so that it expires within like an hour, 30 minutes, or whenever you need it. The third is you can batch requests. Now, for instance, any sort of application will have tracking there, and every single tracking event should be registered and sent to the server, right? But if you're sending each one at a time, then it can cause a lot of overhead to the server and it can be expensive. So it's best to just let your page load, gather all your tracking events that you need to send to the server, and batch those requests once and send it once. So group them if possible. The next is image optimization. Now, images, generally speaking, are going to be your most expensive thing on the client, usually, if you haven't optimized them, because images can be very, very heavy. Like you can have terabytes of images, really. Like for instance, if you're working with NASA, those images are massive, right? So you want to work with image optimization tools. So essentially you want to work with some kind of microservice on the back end where when you're requesting an image, you can pull the size that you need and make sure the image is also compressed and tinified. The next is bundle splitting. So if you're using Webpack and React and so forth, the nice thing about it is that you can lazy load the code that you need. And for instance, you can split your code in multiple different bundles. You can have your app bundle, which just deals with the main app code for yourself. Then you have a vendor bundle that could contain things like tracking and other analytical stuff. And then in your app code, you can lazy load what you need, meaning if we're loading the feed, we really just need to load the feed code, right? If we're loading the profile or something, maybe it's part of the feed, but you don't necessarily need to see it right away. You can wait for it. You can lazy load the profile code. That's just a simple example of bundle splitting in action. And just keep in mind, you want to compress everything. You want to compress all your HTML, CSS, JavaScript. So now let's talk about rendering performance. So there's a lot to cover here. But first and foremost, you want to make sure your UI is mobile friendly. So use media queries for that in CSS. The next is that you want to try to avoid race conditions in your code. For instance, if you have a stock trading app and it's maybe returning a lot of data at once from the API, you might want to batch them and avoid race conditions, because what if one API request comes before another? You want to make sure the order that you return them are the same ones as you requested them. So you want to avoid any kind of race conditions like that. The next is the application cache itself. So you want to make sure you're using some sort of like smart caching strategy on the client too. When you pull the data and you parse it, you can consider caching that data. You can use different mechanisms like local storage, session storage, cookie storage, and so forth. Then the other rendering performance is handling success, error, and loading states. It's proven that if you show some kind of loading states before your data actually loads, your users are more likely to stay and want to engage with your website. So show some kind of preloader, handle what happens if there's an error, maybe show a toast, handle what happens if there's success, and so forth. Then you want to consider server-side rendering, and you can use a framework like Next.js for that. Server-side rendering essentially is mainly for React.js. It helps you take your client-side React code and bring it onto the server, and that helps with SEO and just overall latency because the site loads faster. So consider server-side latency too and talk about the pros and cons of that. The next is you want to defer non-critical resources. So when you load your page, load what is most critical and defer the ones that you don't need right away. For instance, you might not need some sort of third-party library right away, so you can defer that so it's not blocking the initial rendering of the page itself. You want to focus on the above the fold content. what that means is focus on what is rendered on the user's screen immediately. So for instance, if you're on web, you might have, I don't know, maybe 1,000 pixels of space on the front that you want to focus on and render that. Everything below you can consider infinite scrolling it or lazy loading it later or so forth. So focus on above the fold content first. The next is time to interactive. So this is essentially trying to understand how long it takes for you to load your page and for the user to be able to interact with it. So it's divided into multiple steps. The first step is the first contentful paint. That's essentially what is the first thing that's painted onto the screen. It could be as simple as the background color. So that's the first thing that's painted on the screen. Then you can log a network request start to the server. So when you are starting a network request, you send a server request, the server logs it. Then you can log a network request end, meaning you receive the data. And finally, you can log when your component is rendered with that data and it's ready to use. And that will give you either a P50, a P75, or P95. Those are just percentiles, letting yourself know, okay, on average, or on the medium, on P50, how long it takes for users to load our site and so forth. You can also use different built-in Chrome extensions like Lighthouse to understand that, but take it with a grain of salt because you're just one sample size. If you really want to understand how long things are taking, you need to have a larger sample size and essentially eventually hit stat sig, even with TTI, so you have more confidence that, okay, this is the P50, this is the P75, and this is the P90, and so forth. Then you want to preload the JavaScript when needed. So there's a rel preload tag on HTML. You can preload certain JavaScript that you might need. Then you also want to just import what you need in your code. So for instance, if I have a file, and this is a helper file, okay, and this file can have maybe, let's say, 1,500 different functions, okay, and I want to just reference maybe 2 or 3 of these functions in my file. I have 2 options. My first option is I can import the entire file and cause the bundle size to become much larger than it needs to be. Or my second option is I can just import those 2 functions that I need. So import what you need. That will help a lot. Okay, next we have tree shaking, which is essentially eliminating dead code from your bundles. So a lot of times as the app scales, you end up removing old libraries, you end up having old libraries, for instance, Lodash or some other library that you might not be using anymore, but it's taking up a lot of space and there's some legacy usage of it. So you can eliminate dead code, eliminate unused bundles, and that will help a lot with performance because your overall bundle size will be reduced. The next is virtualization. So in virtualization, basically what this means is that imagine you have a really long list. For instance, imagine we're building a news feed and we have a bunch of feed items in there. Okay, so we have a lot of feed items. So you have a long list of feed items. Instead of keep adding in new feed items nodes onto your HTML, instead, imagine you have a fixed number of feed item nodes, maybe like 20 of those. What you do now with virtualization is instead of adding new nodes, you replace the content of the existing nodes with the new content that you receive from the server. This helps with performance on the client too. The next is CSS related stuff. You want to avoid view flows, which is essentially re-rendering the entire page again or that entire component again. You want to try to use CSS animations instead of JavaScript animations, as CSS animations are more performant. And you want to inline CSS in JavaScript when you can. For instance, if you're building individual components, rather than just keep adding CSS to your main CSS file, you can build a CSS in JS for that component, so it's only really used when it's imported. Last but not least, you want to consider rate limiting your requests. So consider how you can limit the number of requests being made to the server. For instance, if we are building a search engine, as the user types their query, on every keystroke, it might be sending a lot of requests to the server. So you can debounce that request. So you can send it within specific intervals rather than sending all of it at once. Or on the other hand, throttle is when you are, for instance, if you're resizing your page and you might not want to trigger some kind of expensive function on every single pixel when it's resized, you can throttle that, meaning that only do it in specific set intervals. By the way, for debounce and throttle, these are common front-end engineering interview questions on how to build those functions from scratch. I have videos on how to do that on FrontendLead.com, so definitely check that out. And then last but not least, we want to cover accessibility and security. So accessibility related topics. So the first and foremost is try to use REM font sizes, meaning that if someone zooms in on the browser, if they change their font preferences on the browser, our site will automatically adjust to it. You want to also cross-device test for compatibility. There's so many different devices, so just make sure you're testing across different devices. Make sure your UI looks friendly across all of them. You want to ensure proper contrast in your content. For instance, you might want to support dark mode for some users who prefer dark mode and so forth. Then you want to also support keyboard navigation, and this is mainly tab navigation if one person is tabbing from one page to another. One component to another, they can support that with tab navigation. Then you also want to support HT5 semantics, like semantic tags, such as like nav or and different tags like that. Last but not least, and this is probably one of the most important ones, is you want to support different ARIA roles across your application, like different ARIA roles for input fields, form fields, and so forth. So that's accessibility in a nutshell. And then the last thing is security itself. So there's really mainly 3 to 4 main topics when it comes to security. The first is course itself, which is essentially course cross-origin resource something. I don't actually remember exactly what it stands for, but basically it's a policy that tells the clients that, okay, this sort of content from a server can be accessed only from this domain, or it can be accessed from other domains. So you set these rules yourself so that other websites aren't able to access your content. They'll get this course error when they're trying to access your content. The next is rate limiting. We already discussed this before, but to prevent any kind of like DDoS attack, you want to try to rate limit your requests so that when it's received on the server, it's not all sent at once. It's sent between certain intervals. The last but not least is XSS. This is the most important one. This is cross-site scripting attacks. Basically, people can inject their own JavaScript into your web page, and if your web page can communicate with your server, that's pretty bad because people have the ability to basically hijack your backend from the client using plain JavaScript. So you want to make sure that your text nodes parse for various like JavaScript tags, like the opening tag, closing tag, and so forth. So that's XSS in a nutshell. And I think we have gone ahead and covered the entire framework here. So yeah, hope you guys found this video helpful. If you did, I appreciate it if you guys subscribe and press the like button, and hope you guys have a great rest of your day. Thanks, take care, bye.